In this video, we're going to talk about how to solve a cosine equation. Right here, I have a cosine graph. Remember that on the x-axis of a cosine graph are angles in radians, and on the y-axis are the trig values. I want to solve a basic equation of cosine of x is equal to 1/2. In other words, the trig value is 1/2. Well, the trig value is 1/2 about right here, because that's 0.2, 0.4, 0.6, 0.8, so 0.5 would be right here. And if I go over to here and go down, this is where we are at pi over 3 as an angle. So we know that if I were to take the inverse cosine of both sides of this equation, so in other words, the inverse cosine of cosine of x, and then this would be the inverse cosine of 1/2. So basically taking inverse cosine of both sides of the equation, I would end up with x equals the inverse cosine of 1/2. You know that the principal angle for that is in quadrant 1. I would get pi over 3. However, you can see from the graph that there are lots of angles that have a cosine value of 1/2. There would be this angle, and this angle, and this angle, and this angle over here. Quite a few angles that have a cosine value of 1/2. So how would I figure out other angles that have a cosine value of 1/2? I think you can see from symmetry here that another angle that would have a cosine value of 1/2 would be the opposite of pi over 3, negative pi over 3. This is what I would call the secondary angle. We pick the angle that is closest to 0, and since these are equally close, we're going to go with the positive one as the principal angle. The other one that is equally close is negative pi over 3. So two solutions of this equation are positive pi over 3 and negative pi over 3. However, there are more solutions, and if this graph extended, there would be an infinite number of solutions. So how do we find the other ones? Well, let's think about where these are located, the other solutions are located. If I took negative pi over 3 and added 2 pi to it, I would get to this next angle right here, whatever this angle is. So negative pi over 3 plus 2 pi minus pi over 3, this is going to be actually 5 pi over 3. And if we took pi over 3 and subtracted 2 pi, this would be negative 5 pi over 3. So that gives us two more angles. Notice that if on this regular cosine graph, that all of the angles with the same trig value are exactly one cycle apart, either in the positive direction or the negative direction. Notice also that there are angles that are on the downward side of the curve and angles that are on the upward side of the curve. So if I add 2 pi to the angle on the upward side of the curve, I will get another angle a period away that is also on the upward side of the curve. If I were to extend this curve down, I could add 2 pi to the pi over 3 and get another angle on the downward side of the curve that would also have a trig value of 0.5. So I could keep adding 2 pi or subtracting 2 pi over and over and over and getting additional angles. So we say that the general solution, so let's go back to principal solution first of all. Principal solution of cosine x is equal to 1/2 is x is equal to the inverse cosine of 1/2, which is pi over 3. However, the general solution of cosine x is equal to 1/2 are all the angles that have a cosine value of 1/2. So I would say x is equal to inverse cosine of 1/2, and that would be pi over 3 plus 2 pi n, because I can keep adding 2 pi to get additional solutions, or negative pi over 3, the secondary angle, plus 2 pi n. Together, those are going to give me all of the possible angles that have a cosine value of 1/2. So this is known as the general solution. In the next video, we'll look at an example of how to use that in a more general cosine solution that has the amplitude, the sinusoidal axis, the phase displacement, and the period all changed. So this is just your basic cosine graph. What happens in a more general graph?